Morning, Mercy.
Good morning, teacher.
How are you? Last week, what did we introduce? So I have just arrived from Kabari, so I don't recall very well. But I think we had introduced, we did motion on an inclined plane, right? Did we? We had introduced resolving. As you don't recall. The rest, good morning. I'd like someone remind us where we stopped last week. In mechanics math. When I finish teaching, you close the books forever. Eh? Doesn't anyone recall where we stopped in mathematics? Mechanics. Hmm? Who is Ivy? Ivy, are you Namirembe? Ivy, are you the Namirembe?
Yes, teacher.
Okay, you're welcome. I was asking people who were here last week, and I was asking whether they recall where we stopped. But it looks like they don't recall. I don't know whether they're not doing numbers. I told you in math, if you don't do numbers, you're going to run into problems. But I recall had we introduced resulting forces? Just tell me the area. Me, I will know where to start from. Mercy. Mercy, had we started on resolving forces? Mercy has disappointed. Biruji Shakira. Where do you think we had stopped in mechanics?
We had not yet started resolution of forces.
But we did motion on an inclined plane. Eh?
Yes.
Okay. Then we are supposed to start on resolution of forces. Now, in mathematics, I started teaching it in physics. That's why I think I get confused a little. But in physics, we don't do a lot of it. We do a lot of the mechanics problems in mathematics. So in math, that's why you see me delay on a topic, while in physics, I hurry to summarize the topic. Okay. Resolution of forces and resultant of forces. This can be called resultant force. Now, from Newton's laws, whereby the rate of change of momentum, which is said is directly proportional to the applied force. I mean, direct proportion to the rate of change of momentum is directly proportional to the force applied. It is from this definition that force is equal to a constant times m, because this is directly proportional to mv minus mu over t. So the rate of change of momentum is directly proportional to force. So mv minus u over t, if you recall from equations of motion, v minus u over t is a, because it comes from v is equal to u plus at. So for Evelyn, who came today, when you take the u on the other side, it becomes that, then you divide off by the t. So it means that force is equal to K MA. And if a force of 1 Newton acts on a mass of 1 kilogram, that is accelerating at a rate of 1 meter per second squared, then the value of K also becomes 1. Yes, Evelyn?
Okay, so I was asking, the K stands for constant, but then where is the constant coming in from?
When you remove the proportionate sign, the constant is the one that it becomes what we call a constant of proportionality.
Oh, okay.
Yeah. But in mathematics, we should not worry so much. What we wanted is to know that this is always what we call the resultant force, whereby the resultant force is always the product of mass times acceleration with which the body is moving. Since we had just finished discussing linear motion and acceleration, then we know what acceleration means. So we know that if you multiply a mass times acceleration, what you get is what we call the resultant force. So, properties of resultant forces. Properties of resultant forces. We have 1. We add together forces facing in the same direction. That is case 1. What does that mean? If all of you are offering mathematics, now all of you are in this same class. None of you is away because you are all facing in the same class. Which class is the black? It has a blackboard or whiteboard for mathematics. So all of you want to be in the math class. If all of you want to be doctors, then your direction is the same. So we add all of you together, those who want to become doctors. Those who want to get degrees, you also add it together in the university. Those who want to get the Uganda Advanced Certificate of Education, you are added together in HSC, okay? Not in O-level, not in primary 1, not at home. The second one, when forces face in opposite directions, we subtract them to get their resultant. Get their resultant. Then Roman 3, what does that mean? It means that if you have senior 5s who are offering sciences and senior 5s who are offering arts, however much they are all senior 5s, they are all in A level. They all want to get the advanced certificate of education. They all want to go to university. If you add those concepts which combine them, you add them together. But if you come to realize that these are science students, they are offering pure mathematics. The other ones are art students offering history, Napoleon Bonaparte. What do? You separate the historians in another class and separate the mathematicians to another class. That is what we are saying. You subtract them off from each other. It means you take away those ones which are not having the same combination. Then 3, if forces face at right angles, face at right angles to each other, we use Pythagoras theorem. That if you get forces which are perpendicular to each other or at right angles to each other, then we shall borrow Pythagoras what? Theorem. So with that sense, they will be solving the forces and getting their resultant by using Pythagoras theorem. And then the 4th one, if forces act at an angle theta greater or equal to 90 or less than or equal to 90. Sorry, less than 90, not equal to. Less than 90. Then we sketch an appropriate vector triangle of forces using the parallelogram law, as we shall see. So those are the 4 properties that we are going to discuss, that we are going to see we can borrow or we can use to always find the resultant force of forces. So with that, we can look at examples. One, I have a body having forces in that direction. More examples will be seen in understanding. This case of subtraction and addition does not worry so much. Does not worry so much. Let this one be 8. Let this one be 4 newtons. So that is the case. Let's first look at these examples. Now, example 1, I said if forces facing the same directions we add. So Roman 1, the solution will be 7, because we are adding in the horizontal direction 7 plus 3 plus 5. They are all going in the same direction. And the answer will be 15 newtons to the right. Or you can say in the direction of the 7 Newton force. When you come to Roman 2, check this out. We have 5, 6, 3. They are in the same direction, so you add them. But there is also 10 in their direction. Also add it there. Then there is an 8 in an opposite direction. You take it off. So we shall get 24 minus 8. The answer will be 16 newtons. That is coming in as a result of subtraction of forces that are facing in the opposite direction. Then that last one talks about two various examples. One, you first induce what it becomes. So you can induce, because you saw this way, it has 1, it has 3 newtons. And this way it has what? 9 newtons. Then here it has 8 newtons. Then here it has 4 newtons. Draw a new diagram merging the forces. For example, up, it is 12. Then this way, it's going to be 9 minus 1 plus 3, which is 5 newtons. Therefore, what does that mean? It means that we sketch a right angle triangle from here. Whereby the 5 is facing this way. So you draw it as you see it. Then the 12 is facing up. So this is what they call an appropriate vector right angle triangle with arrows following each other. By putting the head of this force, which is 5, on the tail of the other. I can also start with a tail of 12. Then I end with the horizontal component, which is 5 newtons. Now, having used the one which is completely marked, then I can say tan of theta is equal to 12 out of 5. You can find for me that theta. Then to get the resultant, this is the line of the resultant. You will say r squared is equal to 12 squared plus 5 squared. So r will give me 144 plus 25 under the root, which r will give us 13. And r is basically what? 13 newtons. What angle do you get so that you can confirm the direction? Someone get us an angle? Yes, please.
Page 1.
What do you get?
I want you to go back to page 1 and take a screenshot.
Yeah, you want to take a screenshot? Eh? To go back where?
Yes.
Go ahead and take 1. Now, sometimes they'll bring a question when it is direct. What angle have you got? Has someone got an angle? That is tan inverse of 12 out of what? Fine. Evelyn, you remind me and I add it to the WhatsApp group.
67.4 degrees.
67.4 degrees. Seven point four. So because it is in this direction, facing this way, can say 67.4 degrees above the 9 Newton force. If you put a compass, then tell us the angle here going north. West, 67.87 degrees, going what? North. Or north, 90 minus 67.87 degrees, going west. 90 minus that answer you've got, what do you get?
$22.6 degrees.
And 2.6 degrees. So you get north and the 2.6 degrees west. Or another can use bearing. Put a compass from north up to where you are. But remember, this one is 67.87. This one is 270. So 270 plus 67.28, what do you get? You'll get 337.87. And this is you're using what? Bearing. I'd say there's another example they can give you. When the forces are just two, one acting up, one acting down. So what you do, you use the law which says, we use Pythagoras theorem, but we first sketch an appropriate vector triangle, which when sketched, you join the force, the head of one force to the foot of the other. What do we mean? I can join the foot of the 3 Newton force and I join it to the foot of the 4 Newton force. This is the force bottom, this is the force top. So the head and the top are meeting, but the head is for 3 Newtons, the bottom or the tail is for 4 Newtons. Then this will become the resultant. You only sketch it if those arrows follow each other. Therefore, the resultant force would be the square root of 3 squared plus 4 squared. And the answer is 5 Newtons. Then you must also get the direction. So alpha is tan arc 4/3. What do we get?
$53.1 degrees.
3.13 degrees above the 3 Newton what? Force. Compass, no, 36.87 degrees. Going east. The other one can also say east, 53.13 degrees going where? North. All those are possible ways you can conclude on that number. Even your hand is up.
Okay, sir, I was asking when you're trying to determine the direction. Okay, when you had north and west, but I had north and east because my diagram was drawn like this. So when I do the compass, my direction was north and east, not north and west.
If this arrow faces this way, you see that?
Yes.
The arrow is going west. Then as it reaches here, it proceeds to what? To north, not? So we are going west of north at an angle of theta. That is why the angle is used. And that tangent is used there. It's not because that if you put here and you draw it like a quadrant, you can't draw it here like this. Here the curve is not passing. Here down. The line will not pass there for the triangle. Okay. Any other concerns? Let's go to the fourth law. The parallelogram law. The parallelogram law. It is similar to what I've showed you on this triangle, whereby, for example, that triangle we saw it was 3 newtons followed by 4 newtons. The resultant is here. But it is the same thing. Someone is to start with 4, then follow it with 3. So if this one is up like this, it will be 4, 90, this one will be 5. So someone can still sketch that and get the right answer. Now what if we have one force acting on a body and another is acting a different force angle? Then we can sketch these two forces with the head of one force on the tail of the other. If I start with P, this can be Q. P, I want to sketch horizontal. Positive horizontal. Q is also positive vertex. So in this sense, you have that this is P, this is your Q. This is Q and this is P. Then the angle between them we have seen is what? Theta. So according to how things go, we end up sketching that angle there. Then this becomes your resultant. So the resultant can be solved using what we call this cosine rule, which is 2 squared plus, R squared is equal to 2 squared plus p squared minus 2p cubed. Cos, as well as, if you have 2 squared plus p squared minus 2p2, cos of the angle opposite here to r, which angle is theta. Then you can make r the subject from p squared plus 2 squared minus 2p2 cos of theta. I'm going to show you how that rule is in general terms, how the rule looks like. But if someone also had started with wait, I think I've sketched it wrong. Something is missing here. It was supposed to be like this. Let me resketch it. We are supposed to have sketched P, then we follow it with Q, so that these arrows follow each other. Then from here up to there becomes our resultant R. And the angle opposite to R is theta. Then this one can be alpha, this one can be beta. But if I'm to start with the Q, then I can end with P. Still the angle here would be theta. The resultant should have been the same line. This is what we call the line of the resultant. So with this, you're using the parallelogram. That's why it looks like a parallelogram. Eh? Now, this is what we have called the cosine rule, which we use here. Find the resultant force. You can even find its angle alpha using the sine rule. If you have a triangle, let me first review that one. If you have a triangle A, B, C, this one will be angle small b, this one will be angle small c, this one will be angle, sorry, this is angle capital A. This is small b. Distance here is small a, small b, small c. Opposite sides to the angles they are at, you have small c out of sine capital C is equal to small a out of sine capital A is equal to small c out of sine capital C. Sorry, already written capital C, so I can use small b. I use small b, I will have small b out of capital B. So if I want to get the angle alpha, I will say alpha is opposite to Q out of sine alpha is equal to theta, theta is opposite to R out of sine theta is equal to S. Sorry, I've done Q, I've done R, I'm left with P. The opposite angle to P there is beta. Then I can use any pair of this relation to deduce any pair of this ratio to reduce the what we call the sine rule. The triangle. So the principle we are using there is the sine rule of the triangle. Then this one is what we call the cosine rule. Take a screenshot, we look at an example. Are we there? Okay, if you have taken the screenshot, they can ask you to find the resultant of the forces. So there are two forces, they're acting at angles. We have said you sketch one at a time. I can start with a 7. I follow at its head and I attach a 5. And then my resultant will be along this line. This diagram you sketch with a ruler. Or I could start with a 5. And then end with a what? The angle out there is 60. You see that the angle in here is 120. So the resultant R squared is equal to 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 120. Press the calculator. Eve, when you press the calc, what's the cosine of 120? Evelyn, cosine of 120. Someone press the calc and give me the answer.
Negative a half.
Negative. Yeah, it's negative a half for cos of 120. So when you substitute, you'll have R is equal to square root 49 plus 25 minus 35 times 270 times negative a half. Here once, here 35. Negative 35 plus 1 negative, you get a plus. You get root of 35 plus 25 is 60. That's 9. Root of 109. That's the best answer. If you write decimals, you write to 4 decimal places minimum, unless they have stated. Now, we need to get the direction here. I can use alpha and 120. Alpha is opposite to 5 out of sine of alpha is equal to R out of sine of 120. What is sine alpha will be 5 sine of 120 divided by R. When you divide by R, so I have divided already by it, so sine of 5 sine of 120 divided by R, which we got as root of 109. This is sine arc. What angle do you get? Sine arc of 5, sine 120 over root of 109. I've not added this. Remember, take screenshots. Answer. That conclusion for the angle is very sensitive. People conclude longly and they score 0. So that's why I want to confirm those answers. And I show you how to present them. Then I'm going to break off very early at 10. I will not use the extra 20 minutes. Work is done. As I still have a lot of fatigue, so we're going to stop at this example. I'll send more examples and more numbers. Then before I begin resolving next week, I'll first review some 2 or 3 numbers. So what is sine inverse of 5 sine 120?
24.5 degrees.
24?
0.5 degrees.
44.5.
24.5. 24.5.
Okay, thank you. How do you conclude? 24.5 degrees above 7 Newton what? Force. And they say 24.5 in terms of compass, you put it there. Then we know that it's facing where? The north is facing up, so it will be east 90. Will be east 90 minus 24.5. 90 subtracts off 24.5. As it comes from north, the remaining angle will be 65.5. So it will be north 65.5 degrees going where? East. On the bearing 065.5. And any other thing that can come up in terms of concluding for the angle. Others want to use the x-axis and y-axis, then you come here. And put for us y-axis. Then you prolong this line and make it x first. Make it x-axis. Any questions so far? Questions there? Or I give you one to try out.
Give us one to try out.
Find the resultant of that, of the two forces. That one. Also this number. So you have Roman 1 and Roman 2.
Sir,
Yes, please.
I'm not getting how you get that 24.5. So, sir, you're muted.
Yes, you were saying how I got the 29 point, my
24.5.
the 24.5.
Yes.
Aunt Kakati, this was 5. Let me show you. This 5 cross multiplied with this one. Okay?
Yes.
This one went up also. Use a different color. This one went this way. This one also went that way. Right? Yeah?
Right.
So idea it became
Right.
5 sine 120 is equal to R sine of what? Alpha. Then we made sine alpha the subject. That's why I divided off by alpha. It became sine alpha. I mean by R it became this. Are we together?
Yes.
Then I said alpha finally is sine arc of what? Of 5 sine 120 divided by R, which was root of 109. Let me press the calculator. You know how to press the cal?
Yes.
First press 5 sine 120. Yeah?
It's giving me
Divided by
4.3301.
root 109. Are you there? What answer do you get?
0.4147.
Shift sign answer.
$24.5.
I think you've seen.
Yes, thanks.
You're welcome. So guys, you finalize with these two numbers. Let me see. When you finish, send me the solutions on WhatsApp. You send to the group. Let me also add this. Okay. My things for you. Let me also add this new lady so that she can get to the group. We can send her all the textbooks, all the work we have been getting in a way of helping her be initiated into the group. Evelyn, I'm sending you a WhatsApp link so that you can click on it to join the group where we make communication of any items. So today we are just looking at how we have summed up or how we have got resultant force. Next week, we are going to resolve for these kinds of numbers, like these ones I've given you. How do I resolve them? And I get the resultant force.
So can I please take the screenshot of the first page?
First page. There's that
The
one.
first one.
There's that one. There's this one. Okay.
Yes, that one.
Yeah, take summarize and make your own notes. You done?
Yes.
Okay. As you're going to try out those numbers, let me hint on something on resolving. But why don't you start with resolving next time? Let you guys finish these numbers. Resolving will be the key definition, then we proceed. Okay. Sorry, today I have to break off early because of some inconvenience. So with that, allow me to stop here. Meeting for physics. We meet for physics after lunch. Then we meet tomorrow, God willing, for pure mathematics. And I mean, tomorrow for, pure mathematics and Friday for trigonometry. Okay, have a good day.